Hello, the objective of this video is to learn how to multiply and divide numbers that are in scientific notation. Now, you'll see here that we have a number in scientific notation right in here, and that we can tell it's in scientific notation because it has an exponent on a power of 10, and the first factor here, that first factor, is between 1 and 10 in value. It's got to be greater than or equal to 1 and less than 10. The multiplication symbol, you may see this as a dot in some places, but it really should use an X for times in this. The second factor is always a power with a base of 10, and the exponent must be an integer, positive or negative, but definitely one of those counting numbers. Okay, so here is an example of multiplication with scientific notation. If I were to expand these out, this would be 3,000 times 200. And in this particular case, these scientific numbers are not that large. But when we go to multiply them, if I set this up vertically like this, I would then want to do, the multiply, get the 0, 0 here, 2 times 0 is 0, 2 times 0 is 0, 2 times 0 is 0, 2 times 3 is 6. I'd end up with 600,000, which I would then have to convert back to scientific, moving the decimal 1, 2, 3, 4, 5 place values. That would give me 6 times 10 to the 5. Now, that's not too bad with these low exponents, but if those exponents were 30 or 40 or 27 or negative 52, you wouldn't want to be writing those numbers out like this. So to do that, we're going to take a look at this. We're going to look at the fact that all of this is being multiplied. If it's all being multiplied, because we have the commutative property of multiplication, we can change the order and make this 3 times 2 times 10 to the 3 times 10 to the 2, which is just moving these to the end there, and then the first factor to the front here. 3 times 2 is 6. Like base is being multiplied, I can add the exponent. So I'm going to get 10 to the 3 plus 2, which is going to give me an answer of 6 times 10 to the 5th power, which is the same answer I got before. So it is going to give me the same answer if I work with the first factors being multiplied, and then I add the exponents of the powers of 10. Let's try it out with these two examples. All right, so I'm going to rewrite this as 4 times 2 times 10 to the 5 plus 3, adding the exponents on the power of 10. 4 times 2 is 8. 5 plus 3 is going to give me 8. And remember, I should have this as an x in between for scientific. I get 8 times 10 to the 8th. That's my final answer there. Down here, I would do 3 times 5 for the first factors. And then for the powers of 10, I would add the 7 and the 2 for the exponents there. This would give me 15 times 10 to the 9th power. Now, unfortunately, this is not my final answer because this number right here, that first factor, is greater than 10, which means I'm going to have to move the decimal over one place value to make the value between 1 and 10. That makes this one place value less, which means I have to make the exponent one place value more. Otherwise, my value would not be the same. So if I make the first factor one place value less, I have to make the exponent one place value more to give me my final answer of 1.5 times 10 to the 10. So these are your basic steps for multiplying scientific notation. Step 1, multiply the first factors. Second, step 2, add the exponents. Now, when you add the exponents, they're still going to be on that power of 10. They're still going to be on that There's still going to be that times 10 on the end there. It's just that whatever the exponents add up to, they're going to be the new exponent on that power of 10. Step 3 is to combine your answers, combine them, and make sure the number is in scientific notation. Remember, the last answer for the question ended up being a 15 times 10 to the 9. That was the combined factor, but it wasn't in scientific notation because the number in front was greater than 10. So we had to make that a 1.5 times 10 to the 10. That's what it means to make sure that that your number is in scientific notation in the end. If the answer, the first factor is greater than or the first factor needs to be greater than or equal to 1 and less than 10, or you're going to have to adjust it like we did here. Okay, let's look at dividing. When you're looking at dividing, here we would have, well, this particular problem, I don't like it when it's side by side. I prefer to see it as a fraction. So the first thing I'm going to do is rewrite this as 8 times 10 to the 5 over 2 times 10 to the 2. And when I've done that, it kind of looks like those expressions I was working with, simplifying with the exponent expressions. Here, these two are two numbers that we can simplify as a fraction. Here are two like bases that we can simplify the fraction. 8 divided by 2 gives me a 4. Still going to be multiplying the result of this second part here. Like bases being divided, we subtract the exponent. So we're going to get a 10 to the 5 minus 2, which results in 4 times 10 to the 3 as our final answer on that one. So it looks like, just like with the multiplying, the first factors are going to be divided, and then for the power of 10, you would subtract the exponents. Let's look at the next example here. Okay, here we're going to have the 1.2 divided by the 3. And that result is going to be the 10 to the 8th divided by 10 to the 3rd. Taking the 1.2 divided by 3 to the side, that would be 3 goes into 1.2. 3 does not go into 1. Bring up the decimal. 3 goes into 12 4 times. So 1.2 divided by 3 is going to give me a 0.4. All right. And then I'd subtract the exponent. So we're going to have a times 10 to the 5 minus, 8 minus 3, which would give me a 0.4 times 10 to the 5. But there's a problem with this one. Notice that the number in front here, that first factor, is less than 1. I'm going to have to move the decimal over 1, which is making this 1 larger, which means the exponent needs to become 1 smaller. So I end up with 4 times 10 to the 4th power. And that would be my final answer there. So here are the basic rules for dividing scientific notation. You need to divide the first factors, subtract the exponents, Again, the result is still on that power of 10. Combine those two answers to make sure you have the proper scientific notation. Make sure that first factor is greater than or equal to 1, but less than 10. When you are changing the first factor, like we've done a couple of times here, you should note that for every place value larger, you make the first factor, by moving that decimal, you have to take away 1 from the exponent on the power of 10. First larger, second smaller, makes the value stay the same. This last sentence is not proper English, but it should help you out. If you make the first factor larger, you got to make the exponent smaller, which makes the value stay the same. For every place value smaller you make the first factor, you have to add 1 to the exponent on the power of 10. First smaller, second larger, keeps the overall value the same. If you make the first factor smaller, you've got to add to the exponent to make the second value larger. Otherwise, the overall value of that scientific notation number will change. Thank you for watching. See you in class.